Next section of chapter 11. Hope everybody had a good weekend or whatever. Hope you had a great weekend. We're going to start section 3 of chapter 11 today. Start it and probably finish it today. We're going to do several things. We're going to define what a logarithm is. We're going to start talking logs again. We'll talk converting between exponential and logarithmic forms. We're going to solve some logarithmic equations of the form log base a of b equals k, for at least for a and b. We're not going to graph them too much, and we might solve some growth and decay type of problem. So first of all, what's a logarithm? For all positive numbers a with a not equal to 1 and all positive numbers x, y equal to log base a of x means the same as x risen to the ay power. So there's two different forms. There's what we call logarithmic form, there's what we call exponential form. Logarithmic form is anything that has the word log in it. So y equals log base a of x. That's a logarithm. Exponential form or an exponent form is x is equal to a to the y power. So what we want to be able to do is we want to be able to switch between these two powers. So a couple things you need to notice. We've got this exponent sitting, they've got this y value. In logarithmic form, that y value becomes the exponent. The base is this being down here. It's kind of a subscript down there. That base becomes the base in your exponent form. And we want to be able to go between these two different forms. So essentially these two things are equivalent to each other. Okay, so what I like to say is I like to write it a little bit different than this. I say log base a of b is equal to y. That this is equivalent to a to the y power equal to b. That those two things are equivalent to each other. And ay equals b is equivalent to log base a of b is equal to y. So those two things are equivalent to each other. And we want to be able to take these and write these in each form. So if you're given something in logarithm form, you want to be able to write it in exponential form. If it's given to you in exponential form, you want to be able to write it in logarithmic form. We want to be able to boot between kind of those two things. So we're going to start out by converting between exponential and logarithmic form. Okay, so if we look at the first one, it's an exponential form. We got 3 squared equals 9. So up here, remember, so we said that this was a to the y equals b. And then we said that that was equivalent to log base a of b is equal to y. So we're just kind of replacing these. So we've got 3 squared equals 9. So this becomes log base 3 of 9 equals 2. What was the base? So this is kind of the base of exponential form. That becomes the base of the logarithmic form. What's on the other side of the equal sign becomes our of, and what was our exponent becomes what we're equal to. So if we've got 1/5 to the negative 2 equals 25, that's the same thing as log base 1/5 of 25 equals negative 2. 10 to the 5th equals 10,000. Log base 10 of 100,000 equals 5. 4 to the negative 3rd equals 1/64 is the same thing as log base 4 of 1/64 equals negative 3. So that's kind of taking something and taking it from exponential form to logarithmic form. And again, what was our base of our exponent becomes the base of our log. The exponent goes on the other side of the equal sign, and what was on the other side of the equal sign becomes our of statement. So those are what we call equivalent forms of each other. Okay, so we're going to get to this in just a second. I want to do kind of a couple other examples. Let's say that we have now it written as a log. So let's say we have log base 4 of 3 is equal to x. That's in logarithmic form. So now we want to take it from logarithmic form to exponential form. So in exponential form, the base of our log is 4, so we're going to go 4. What was on the other side of the equal sign becomes our x value equals 3. That's our solution in exponential form. Okay, so taking something from logarithmic form to exponential form. Okay, let's go 4 to the 5th equals 1024. This is an exponential form, so we want to take it in logarithmic form. So logarithmic form is going to be log base 4 of 1024 is equal to 5. And there's your solution, and you're done. Okay? So we have to really be able to go both directions. We have to be able to convert them as logs, and we need to be able to convert them as exponents into logs. So let's take one more look at a logarithmic one. Let's do one more one that's written in log, and we'll put it in exponential form, and then we'll kind of move on to this next objective. So let's go log base 6 of x equals 10. Logarithmic form, we want to put it in exponential form. Exponential form, our base is 6 to the 10th power equals x. And there we've taken it and converted it to exponential form. So really, that's really the first part of your assignment for today, is what you need to do with that. The second part of your assignment then is going to be to solve logarithmic equations that are in the form log base a of b equals k. So we want to be able to solve different logarithms. So we've got something like solve the equation log base 3 of x equals -3. Okay, so if we're going to solve this, anytime you're trying to solve something that's in logarithmic form, most of the time the easiest way to solve it is to write it in exponential form. So this is in logarithm form, so let's put it in exponential form. So this would be 3 to the -3 equals x. And we got this handy dandy calculator, so I can go 3 raised, so 3 caret to the -3rd. It's 0.037, blah, blah, blah. It gives us a decimal point, but I want to see if that's a fraction instead. So I'm going to change this to a fraction. So the way you change it to fractions is hit second, then hit the ABC key, and hit equals. Oops, it should have done it, but it didn't. Well, convert, darn you. Well, it doesn't do that. So it doesn't convert that, so just erase what I said. So essentially this would be 1 over 3 to the 3rd, which is 1 over 927. So 1/27th would be what this one is. Okay. I would have taken the decimal, would have been just fine. They like to write it as sign. So the next one. So it says log base 1/3 of 2x plus 5 equals 2. So we're going to rewrite it. We rewrite it as 1/3 to the 2 equals 2x plus 5. 1/3 raised to the squared, I guess. So we got 1/3 squared. I've been having issues with calculators all day today. 1/3 squared. So that's like 0.111. I'm not going to clear my calculator. That equals 2x plus 5. So subtract 5. -4.88. And again, I'm not going to clear my calculator. That equals 2x. So divide by 2. So you get -2.44 is equal to your x value. Okay. If it's in logarithmic form, put it in exponential form. And you're done. Okay. See what they did. They left it as fractions. Same answers as we get. Nothing wrong with that. Okay. Next one. X, log base x of 5 equals 4. Again, I'm going to write it as an exponent. X to the 4th equals 5. How do you solve that? You take the 4th root. So your solution is the 4th root of 5. And you're done. Writing it as an exponent. Plus or minus the 4th root of 5, whatever. Okay? This one's a little bit more difficult. So this is, we would have 36 to the x equals 4 times the square root of 6. See how they do it. I'd probably take the 4th root of it. Okay. Get the bases the same. I don't think we're going to do any that are like this on our assignment today, but again, wherever we're at. A couple properties of logs and a couple things you have to keep in mind. That anytime you have log base b of b, that's going to equal to 1. So if I have something like log base 4 of 4, that's going to be equal to 1. Anytime where the base and the of are the same, it's going to equal 1. That's just what it always is. This would be something like log base 4 of 1 that equals 0. Okay, so anything where your of is 1, the solution is going to be 0. And you think about it, this would be 4 to the 0. 4 to the 0 equals 1 because anything to the 0 power equals 1. So anytime your of is 1, your solution is going to be 0. It's going to equal 0. Anytime your base and your of are the same, the solution is going to be 1. Again, because 4 to the first is equal to 4. So keep that in mind. Okay, so let's go ahead and solve these real quick. These two things are the same, so our solution is 1. These two things are the same, so our solution is 1. Our of is 1, so the answer is going to be 0. Our of is 1, so the answer is going to be 0. Those are your solutions. Okay. We're not going to graph them. You don't need to worry about graphing them. Yeah, that pretty much does it. I want to do one more example of not a graph one, but just one more example of something that we might have. Just one more logarithm one. So let's say we've got log base 2 of 6x plus 8 equals 3. So it's in logarithmic form, so we're going to write it in exponential form. So 2 to the third equals 6x plus 8. 2 times 2 times 2 is 8. Subtract 8. Divide by 6. Okay. So really converting between logarithms and exponentials, converting between exponentials and logarithms, solving for logs. And remember, when you're solving for logs, rewrite it as an exponent. And then you should be good to go for today. Make sure you're completing, make sure you've got 11.1 and 11.2. We're looking at a quiz here in the next couple days. We've got 11.4, and then we're pretty much done with, we have a quiz coming up here probably on Wednesday of this week in the next couple of days. So let's make sure we're getting 11.1 and 11.2 done and getting the rest of our quizzes and all of that taken care of, everybody. Have a good day. See ya.